So welcome to another National 4 chemistry video. This video is going to be the second part of Unit 3. The topics covered in this are materials, specifically plastics, radiation and fertilizers. So it's a few different topics added together. So the first thing we want to talk about is plastics. Now plastics are really important. Plastics covers a whole range of different chemicals with a massive array of different jobs that plastics can do. Now there are two main types of plastic. We have plastics that are called thermo-softening plastics, or sometimes that's shortened to thermoplastics. And these are ones which you make them, but if you heat them up, you can reshape the plastic, which makes it slightly easier to recycle and it has more function. The other type of plastic is one that we'd call a thermosetting plastic. Now, a thermosetting plastic, once it's been formed, if you heat it up, you can't really change its shape. So these are your much more sturdy plastics that would be used for things that you want to last a very long time. Now, plastics are a form of polymer. They are massive molecules made by joining together a lot of smaller identical units, like in that diagram. The plastic is the whole chain, and each individual circle is a small unit that we would call a monomer. When those monomers are added together, or joined together, we call it a polymer. And every plastic is a polymer. Now, when it comes to naming polymers, it's really easy. You will always be given the name of the monomer, and all you need to do to name the polymer is put the name of the monomer in brackets and put poly in front of it. So for example, if the monomer was propene, we can see that the polymer is poly and then propene in brackets. For phenylethene, if that's the monomer, the polymer is poly and then in brackets phenylethene. If the monomer is styrene, then the polymer is poly and then styrene in brackets. So any monomer, all you need to do is put it in brackets and put poly in front of it. Now, while plastics are really useful, they do have some issues. Firstly, when plastics burn, they release toxic gases. So it's not really a good idea to try and get rid of plastic waste by burning it, because you'll be releasing toxic gases which not only will pollute the atmosphere, but may also kill birds and other animals. Plastics are also really difficult to break down. We describe them as being non-biodegradable. And this means that a lot of the plastics that have been used and have been thrown away as litter or find their way into rivers are now gathering in oceans and the general environment, and they're not going anywhere. So they're causing big issues. They are choking animals. They are not only horrible to look at, but they're also a breeding ground for lots of different bacteria. Now, luckily, newer plastics are being designed to be biodegradable, which means that even if they are thrown away, they won't last a long time out in the environment and they will break down, which means that they will not have such a negative impact on the planet. But we will still need to find solutions for what to do with the older plastic waste that is non-biodegradable. Our next topic is nuclear chemistry. Now this is a really short topic. So making new elements. So new elements are formed when the nucleus of one atom and the nucleus of another element combine. This is where we get the word nuclear chemistry from, because we're dealing with the nucleuses or the nuclei of different atoms. Now, a good example of this happening is inside our sun. And in our sun, there is a constant, continuous array of nuclear reactions where hydrogen atoms are being fused together to form helium atoms. So helium is called helium because the Greek word for the sun is helios. So helium is the element of the sun, and it's being made in there constantly. So we actually have to be really grateful for helium being made because it's providing us with all the energy and the light that we get from the sun. And every heavy element out there has been formed inside a star in a similar way. So that means every heavy element that's on Earth, every metal, for example, started out being formed inside a star light years away from where we are now. Now, every time a nuclear reaction happens, we have nuclear radiation going on. And we sometimes think of nuclear radiation as being this really dangerous and harmful thing, and it can be, but we're actually surrounded by a natural level of radiation that we call background radiation. And background radiation can be measured using something called a Geiger counter, which looks a little bit like that picture. We've got a box that's got a dial that moves up and down to show you what the radiation is, but it also has that big sort of black cylinder at the front of the picture, which is what you point at objects, and you can hear the Geiger counter sort of crackle, and it makes like ticking sounds. The more ticks you hear, the more radiation is being given off. And if you were to hold up a Geiger counter to a human, it would be clicking because even we give off background radiation. But some of the main sources of background radiation on the planet are rocks, also just general, the light and the energy that we get from the sun and from other stars provides us with radiation. Different bits of medical equipment use or generate radiation, and also telecommunications. So all of the satellites, all of our mobile phones, all of the radio waves, etc., are forms of radiation that we would detect as well. And that's all we need to know about radiation and nuclear chemistry. Our final topic is fertilizers. Now, the population on Earth has been growing really fast for the past few decades and is set to continue growing at quite a fast rate. In order to keep the population alive as it grows, we need food. And to grow more food, we need fertilizers. So fertilizers are really important. Without fertilizers, many people would die. Arguably, over 50% of the population, as it currently stands, are only here because of fertilizers allowing us to produce that much food. Without fertilizers, we would not have enough food to feed the planet with the population it has now, let alone the predicted 9 billion that it might reach in the next 10-20 years. So fertilizers are very important to life on this planet, especially human life. Now, what is it that makes fertilizers special? Well, fertilizers contain essential elements. And fertilizers add the 3 essential elements that plants need to the soil. These elements are nitrogen, which gets shortened to N, phosphorus, which gets shortened to P, and potassium, which, though it might sound strange, gets shortened to K. And so when we talk about fertilizers, we often talk about them being NPK. So if you remember those letters, NPK, and try and remember the elements nitrogen, phosphorus, and potassium. Now, if you buy a fertilizer from a garden centre or sometimes from a supermarket as well, can get them, you'll find that written on the packet will be a list of NPK numbers. It'll be 3 different numbers, one for N, one for P, one for K. And that tells you the percentage of that fertilizer that is nitrogen, the percentage that's phosphorus, and the percentage that is potassium. In the final slides on this, I will show you how to work out percentage composition, but most of the time it's written on the package. There are two main types of fertilizers. We have natural fertilizers. These are ones that you do not need to use a laboratory to make. They can be made naturally. So a good natural fertilizer is compost. That's where you take your kitchen or your garden waste and you leave it to rot for a while. It doesn't really smell that nice, but you need to leave it a while. It'll start to decay, and then you can mix that in with your soil and it will act as a fertilizer. Alternatively, you can use animal or plant manure, so that means waste, that you can put into the soil. The second type of fertilizers are known as artificial, synthetic, or man-made fertilizers. These are chemicals that have been specifically made in laboratories for the use of being fertilizers. And most fertilizers are formed from a neutralization reaction, like we learnt from Unit 1. Now, fertilizers, while they are vitally important for sustaining the population on Earth, there are some negative impacts. Fertilizers can leach, or what that means is get into rivers and lakes. So when it rains, fertilizers can dissolve, so then they can dissolve, move with the rainwater into rivers and lakes, and this can lead to something called an algae bloom, which can kill aquatic organisms. Now, an algae bloom is when you get a lot of algae, which is a type of river or water plant, growing on the surface of the water. And it blocks out all the sunlight, which has a knock-on effect of killing other plants. And when those other plants die, it means that the animals living under this algae also die. So an algae bloom leads to just a disastrous loss of life in water, which is something we can't have. We need to have things living in water for biodiversity. And so algae blooms usually look like green scum covering the surface of water. However, some algae blooms are actually red or blue. And it does result in plants and animals, particularly fish, dying, which is really bad. We don't want to kill other animals, kill other sources of food by growing plants. Now, as I said, the final thing for fertilizers is percentage composition. To do percentage composition, we need to remember how to work out our formula mass, and then we'll use the following equation, where percentage mass or percentage composition is equal to the total mass of element multiplied by 100, and then you divide that by the formula mass for the compound. This equation is written, I think, on page 3 of your data booklet. On the page of your data booklet where it's got other equations, this equation is written there. So you do not need to remember this, but if you do, it's helpful. And what I've got are two examples of working this out. First one is our simple example. It's sodium chloride. What is the percentage composition of sodium in sodium chloride? The first thing we need to do is work out our formula mass. So sodium chloride contains sodium and chlorine. There's no numbers written after either symbol, so there's only one of each of them. We then look up our data booklet at what is the relative atomic mass of each element, and we find that sodium is 23, chlorine is 35.5. We multiply them and then we add them together, which gives us a formula mass of 58.5. Now our percentage composition is what is our total mass of sodium, which is what we find under the multiply, which is 23. And we're going to take our relative formula mass, or our formula mass, as 58.5. Our percentage mass is going to be our mass of sodium divided by our formula mass multiplied by 100. So 23 divided by 58.5 and then multiply it by 100, which gives us 39.3%, and that's been rounded up to 1 decimal place. Our second example is a slightly more complicated one, and we have K3PO4, otherwise known as potassium phosphate. What is the percentage composition of oxygen in this? Well, again, we need to work out our formula mass. The elements in K3PO4 are K, P, and O. There's 3 potassiums, 3K, 1 phosphorus, so 1P, and 4 oxygens. When we look up the masses in our data booklet, we see that potassium is 39, phosphorus is 31, and oxygen is 16. And we multiply to get 117, 31, and 64. And to get our formula mass, we add them together, and that ends up 212. Now, we were asked to work out the percentage composition of oxygen, so we're caring about the line containing oxygen. And the total mass of oxygen is going to be that 64, the final thing. Our formula mass is 212. So we're going to use our formula, total mass of element divided by formula mass multiplied by 100. So 64 divided by 212 multiplied by 100 gives us 30.2, and again that has been rounded to 1 decimal place. That has been a quick go through of plastics, of nuclear chemistry and fertilizers, and this concludes the videos we have on Unit 3 for National 4 Chemistry. Hopefully you've gathered all of that information together. If not, have a watch over any of the videos before attempting the questions you need to answer for this unit.